will discuss one of the most important chapter in the maths, which is coordinate geometry. So this is for class 10 CBSE boards, and believe me, it is one of the most weighted chapter in which you can gain about 8 marks. Right, so we'll discuss it in a parts. The first part will see the introduction of the coordinate geometry. We should know the basic terminology or basic terms, basic concept about coordinate geometry. And in the second part we'll see the distance formula. So this is a famous one, distance formula, in which we find a distance between the two given points. So there are certain points given and we need to find the distance between them. So that is about the distance formula. And in the third part we'll deal with the section formula. Section formula, it is nothing but there are given a points, 2 points forming a line segment, and there is a point, certain point P, which divides the line segment into certain x is to y ratio. So we should find which point it is dividing in that particular ratio. And the fourth part, it deals with the finding the area of the triangle when three points are given, right? So we'll see the each and every part. So first let us see the introduction. Right, so we should know the plane. So we always know this, like, okay, so we know this is an x-axis, which is the horizontal axis, is known as x-axis, right? And the vertical axis is known as y-axis. So we know this since from our childhood, right? So yeah, so we need to locate a point P. We need to tell its location. So this plane is known as Cartesian plane. Which plane it is? Cartesian plane, right? So if there is particular point P, which is suppose say 2 comma 5, we need to locate it where it is. Right, how can we locate? First of all, we do the units on x-axis 1, 2, 3, and 4, and on the y-axis same 1, 2, 3, and 4 and 5. So we need to locate this point P, which is 2 comma 5. How can we locate? So first of all, what are these points 2 comma 5? 2 denotes the x coordinate. X coordinate, or this is called as an abscissa. Abscissa. So it can come as an MCQ. What is the x coordinate is called as? It is called abscissa or x coordinate. And the y coordinate is also called as ordinate. Just an ordinate. So it can come as an MCQ in your final exams. Like, what is y coordinate is called as? It is called as ordinate. Right. So we need to locate this point. How can we locate? So any point P that is denoted by x comma y, right? So likewise here 2 comma 5. So on the x-axis we need to go 2 units, so 1 and 2 here, and on the y-axis we need to go for 5 units, 1, 2, 3, 4, 5. So on the y-axis 5, on the x-axis 2. So our point P is located here, 2 comma 5. Right, so we have seen this basic terminology. So what does these x and y actually mean? So we have seen this point P, right? So the distance of this point P from the x-axis, so this is the x-axis, right? This is a point P. Distance of the point P from the x-axis is corresponding to the y part. Y is 5. So this distance is y, right? And distance of the point P from the y-axis, so this is the y-axis and this is the point P. So this is the distance of the point P from the y-axis, which is 2 units, which is its x coordinate. So what does it mean? So the x means distance of the point from the y-axis, and y means distance of the point from the x-axis. So this is the actual meaning. So there might be a question like there is a point A which is 2 comma 7. So they might ask what is the distance of this point from y-axis. So what is the distance from y-axis? Means x coordinate. So x coordinate is 2. So the answer is 2. So likewise many questions might arise from this basic concept. So you need to understand the concept. Only then you can solve the problems, right? Okay, now we understood the basic terminology and let us still go into the basics. So this whole Cartesian plane is divided into 4 quadrants. So we know, no, this is the x-axis, right? And this is the y-axis. So this part is known as positive x-axis. And this part is known as positive y-axis. And this part is known as negative x-axis. And this part is known as negative y-axis. So we should locate the numbers on it. So on the positive x-axis, however it denotes, the numbers are positive. So positive 1, 2, 3, 4 and so on. On the positive y-axis, positive 1, 2, 3 and so on. On the negative x-axis, -1, -2, -3 and so on. On the negative y-axis, -1, -2, -3 and so on. So this is the concept. Now let us understand what kind of problems might arise from this concept. So there may they may say a point Q which is -2 comma 3. I've seen this, I've said this. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay. So first quadrant, second quadrant, third quadrant, and the fourth quadrant. So there might be a question of a point Q which is -2 comma 3. Which quadrant does it belong to? There might be a question. So what is the answer? So first of all, in the first quadrant, the signs of the numbers are, x is positive and y is also positive. So plus comma plus, right? And the second quadrant, the x is negative and the y is positive. So minus comma plus. And in the third quadrant, the x is negative and the y is also negative. So minus comma minus. And in the fourth quadrant, the x is positive and the y value is negative. So plus comma minus. So these are the signs of a particular quadrant. So this is a question of -2 comma 3. Which quadrant does it belong? The x sign is negative and the y sign is positive. So where does it belongs to? X sign is negative, y sign is positive. So it does belongs to second quadrant, right? So now answer me this question. If a point A is located -3 comma -4, which quadrant does it belongs to? Do solve it on your own and tell me the answer. So x coordinate is minus and the y coordinate is also minus. So minus comma minus, it belongs to third quadrant. So this point is located on the third quadrant somewhere over here, right? So now let us go into a deeper. So first we'll see about the distance formula. Distance formula. So what does actually it mean? Distance formula is nothing but, so they randomly give 2 points. Suppose a point P and a point Q which are located over here, somewhere over here in the Cartesian plane. We need to find what is the distance between them. How can we find the distance? Okay, first let us understand its concept and let us understand its applications. How can we find it? So first we'll go with derivation of the formula. You don't need to derive formula always, right? But you need to understand how does this formula come from. From where does this come from? So let us say point P, which is x1 comma y1, and a point Q, x2 comma y2. The coordinates of the point x1 comma y1 and x2 comma y2. So Draw a perpendicular line from the P to the x-axis. This is the x-axis and this is the y-axis. Draw a perpendicular line, right? So what is mean by x1? X1 is distance measured on the x-axis. So this is the x1. And what is y1? Distance measured on the y-axis. So this is the y1, right? Same. Draw a perpendicular line on the x-axis to the x-axis. And what is x2? It is a distance measured on the x-axis. So this whole length is x2. And what is y2? Distance of the point measured over the y-axis or vertical distance. This is the y2, right? So now draw a line, this line. So we need to zoom zoom in into this right angle triangle. So we need to find this distance. What is this distance? So this whole length is x2 and this length is x1. So what does this distance? It is x2 comma x2 minus x1, right? And this whole length is y2 and this length is y1. This distance will be y2 minus y1. So now let us zoom over this triangle, right angle triangle, and let us derive it. So let us say this is a point R, this is a point P, and this is the point Q, right? We have zoomed in this triangle. So this coordinates are x1 comma y1 and this coordinates are x2 comma y2, right? So we need to find this distance, which is the actual distance of the points, and we know this length we have derived it. This whole length is y2 and this length is y1. This length will be y2 minus y1 and this whole length is x2 and this length is x1. So this length will be x2 comma x2 minus x1, right? So let us apply this one. Now this looks like a right angle triangle. We know a theorem which is known as Pythagoras theorem, right? No, Pythagoras theorem, from which we can say this is a hypotenuse. Hypotenuse square is equals to opposite square plus adjacent square. So what is hypotenuse? PQ square is equals to opposite square is QR square plus adjacent square is PR square, right? So what is this PQ? That is something we need, which is the distance between the 2 points. Let us denote it as a D. D square is equals to what is QR square, which is y2 minus y1 whole square, right? What is PR square, which is x2 minus x1 whole square. So now the distance between the 2 points, the famous formula called as distance formula, D is equals to x2 minus x1 whole square plus y2 minus y1 whole square. So this is the beautiful formula from which direct questions might arise, and there might be a 3 marks question or a 4-mark question on it, and there might be MCQs coming on it. So let us see. Let us try, for example, there is a point A which is 2 comma 5 and point P which is 9 comma 2. Okay, so I want to find the distance between these 2 points. Okay, then the half problem is already solved. Just substitute in the formula. So what is this? This is the difference between the x coordinates and this is the difference between the y coordinates. So the distance AP is equals to under root x2 comma x1, or difference between the x coordinates. So this is the x1, this is x2. What is the difference between 9 and 2? 9 minus 2 is 7 whole square plus, and this is y1, this is y2, right? So the difference between the y coordinates, which is 2 minus 5, or it can be 5 minus 2 is 2, which is 3 square. So what is 7 square? it is 49, plus what is 3 square? It is 9 under root. That is the distance. 49 plus 9 is what? 58. So the AP, or the distance between these 2 points, is under root 58. Okay, so now it's your turn. Let us solve another formula, another question. Let us solve another question. If I say, suppose a point Q which is minus 2 comma 5 and a point R which is 1 comma minus 2, I want to find the distance between them. It's so simple, right? Distance D is equals to difference between the x coordinates, minus 2 minus 1 whole square, which is minus 2, x1 minus x2 whole square, plus difference between the y coordinates, 5 minus of minus 2, which is 7 square. So 3 square plus 7 square. What is 3 square? 9. What is 7 square? 49. Oh, it is same as the previous one, right? Under root 58. And now this is your homework. Solve a distance between a point O, which is 1 comma 2, and a point P, which is minus 2 comma minus 3. Okay, solve this and tell me the answer. Comment down in the comment section, right? So now let us see the models, which kind of questions are most repeated in the exams, and what kind of questions come from this coordinate geometry from the first part, which is distance formula. So the first model of question is direct distance. So they might give 2 points, and they'll ask the distance between the 2 points. We have seen 2 examples, and let us see one more example too, which are integrated with the trigonometry or something. So there is a point P which is a sine theta comma minus cos theta, and a point Q which is b cos theta comma sine theta. Right, these are the 2 points we have seen. It is integrated with the trigonometry, right? And we have to find the distance PQ, which is under root difference between the x coordinates, right? X coordinates are this. Difference between the x coordinate is a sine theta minus b cos theta whole square, right? Plus difference between the y coordinates, so sine theta minus of minus cos theta whole square. So we need to solve this. PQ is equals to under root. We have to expand this, right? So a square sine square theta plus b square cos square theta minus 2ab, which is a sine theta into b cos theta, right? Plus here sine square theta plus cos square theta plus, minus of minus became plus, so it's like a plus b whole square, a square plus b square plus 2ab, which is sine theta cos theta. We know this. Sine square theta plus cos square theta is equals to 1. So we need to expand it and just solve this. There is no need to have certain confusion about it. Just apply the trigonometry and solve whatever it can be like. And let us see the second model, which is equidistant. So what does this mean by equidistance? So what does this equidistance mean? So let us say a point P and a point Q lying over here, whose coordinates are suppose 2 comma 6 and 3 comma minus 4. Okay, so there is another point which is, let us say, R, which is equidistant from both P and Q. So this is a question, a point R which is equidistant from both P and Q, and having a coordinate x comma 2. So what is the value of the x? We need to find out the value of x. So they are saying PR distance is equals to RQ distance. So first of all find the PR distance and find the RQ distance and then equate it. Here PR distance is equals to RQ distance, right? Just apply the distance formula and that's it. The problem is solved, right? So what is PR here? Okay, let us copy the coordinates here first. 2 comma 6 and 3 comma minus 4. P is 2 comma 6, Q is 3 comma minus 4, and R is x comma 2. So this R is equidistant from both P and Q. So PR is equals to QR, right? So we need to find the distance. PR is equals to under root difference between the x coordinates, which is 2 comma 2 minus x whole square, plus the difference between the y coordinates 6 and here is 2. 6 minus 2 is 4 square is equals to under root QR distance, difference between the x coordinates, minus 3 minus x. So it's nothing but minus 3 minus x whole square plus difference between y coordinates 4 and 2. 4 minus 2 whole square. Just do squaring on both sides. The square roots gets cancelled and expand this. 4 plus x square minus 2ab. A is 2, b is x plus 16 is equals to. It's nothing but x plus 3 whole square, right? Take minus common and minus out, it becomes plus. So 3 plus x whole square, which is x square plus 9 plus 6x plus 4 minus 2 is 2. 2 square is 4. Just solve this for x. X square gets cancelled, right? And this becomes 20 and this becomes 13. So send this 13 to this side, plus 13 becomes minus 13. So here minus 4x plus 20 minus 13 is equals to 6x. Send this x down to that side here. So here it is minus 4x. If you send that side, it becomes plus. So 20 minus 13 is 7 is equals to 6x plus 4x, which is 10x. So we get the x value which is not real. It is 10 by 7. So this is the x value, right? So this is the equidistance formula, and it is most repeated questions in the PYQs. If you have ever seen the PYQs, so it is most examiner's favorite topic, favorite question it is. So now let us understand another model, which is third model, which is about the collinearity. Collinear. So first of all, we should understand what does collinear mean. Linear means line. Collinear are nothing but the points which are lying on the same line, right? So they'll give a 3 points A, B, C, and they'll give its coordinates, and they'll ask whether these are collinear or not. Find out. How can we find out? So let us understand. If the 3 points are collinear, then the AC distance, which is the total line segment length, is equals to AB distance plus BC distance, right? All this line segment length is AC. This length is AB, this length is BC. AB plus BC is equals to AC. So AC is equals to AB plus BC. And that's it. They'll give the points. We should apply the distance formula for all this and we should equate it. So let us solve an example for this, right? Let us solve an example, then it becomes like cakewalk for you. So let us say 3 points P 2 comma 3, Q 9 comma minus 2, r, which are like 0 comma 2. They'll ask whether these points are collinear or not. Now find out the individual distances. First of all, we'll find out PQ distance, which is under root difference between the x coordinates 9 and 2. 9 minus 2 is 7 whole square, plus distance between the y coordinates 3 and minus 2. Difference will be 5, right? So 5 square. So which is 49 plus 25. How much it is? 74. So this is under root 74. And let us find the QR distance. Right. So difference between the x coordinates 9 and 0 is 9 whole square, plus difference between the y coordinates minus 2 and 2. The difference will be 4 whole square, which is like 81 plus 16. How much? Under root 97. And now let us find a PR distance. PR distance, which is under root difference between the x coordinates 2 and 0, which is 2 whole square, plus distance between the y coordinates 3 and 2. The difference is 1 whole square, which is under root 5. And I don't think really 90 under root 97 is equals to under root 74 plus under root 5. I don't think this is correct. So these points are not collinear. So this is our conclusion. Right, if these are like, if we can equate one distance is sum of the other two distance, then the points are collinear. But here we don't think it is going to be equal. So these are non-collinear, which do not lie on the same line. So this is our conclusion. And now let us go for the fourth model, which is like they'll give 3 points and they'll ask whether this is an isosceles triangle or this is a right angle triangle or this is an equilateral triangle. So we need to find whether this is an isosceles triangle, right angle or equilateral. How can we find? So we should understand the concept. So what does isosceles triangle mean? It means like the two sides lengths are equal in a triangle. So these two lengths are equal, then it is called as isosceles triangle. And to be an right angle triangle, the angle should be 90, but we are here not dealing with an angle, we are dealing with a length, right? So the hypotenuse square is equals to adjacent square plus opposite square. So if this is a condition, then we'll say it is a right angle triangle. And for equilateral triangle, all lengths must be equal. So they'll give 3 points and they'll say whether you should find the lengths. So if 2 are equal, then it is isosceles. If 3 are equal, then it is equilateral. And if this satisfies the Pythagoras theorem, it is a right angle triangle. Let us solve. There is a point A which is 2 comma 3 and point B which is 0 comma 0 and a point C which is 3 comma 2. They'll ask which triangle does it form. So let us first find the distance. Right, so let us find AB length, which is A is 2 comma 3, B is 0 comma 0, C is 3 comma 2. So if we want to find the AB length, difference between the x coordinates whole square 0 comma 2 whole square plus difference between the y coordinates whole square, which is 2 square plus 3 square, 4 plus 9, which is under root 13, right? Now let us find the BC distance. So the difference between the x coordinates, same 3 square, plus difference between the y coordinates, which is 2 square, right? Same 9 plus 4, which is under root 13. And let us find CA distance. C and A. Difference between the x coordinates 3 and 2. What is the difference? It is 1 whole square. Plus difference between the y coordinates 3 and 2, 1 whole square. That is under root 2. So what is our conclusion? Which triangle does it form? We got two are equal and the third one is not equal. Right. If two sides are equal, then it is called as isosceles triangle. Right. Yes. Now let us solve another problem. Let us solve another problem. So if there are points like P, which is 1 comma 0, and Q is 0 comma 0, and R, which is 0 comma 1. So which triangle does it form? So let us solve this, right? So first find PQ distance under root difference between the x coordinates 1 and 0, which is 1 square, plus difference between the y coordinates 0 square, which is under root 1, which is 1. And then let us find the distance between the Q and R under root difference between the x coordinates 0 and 0 0 whole square, plus difference between the y coordinates 1 and 0 whole square 1 square, which is under root 1 is 1, right? And let us find the PR distance, right? Under root the difference between the x coordinates is 1 comma 0, which is 1 whole square, plus difference between the y coordinates 0 comma 1, which is 1 whole square, is under root 2. So same, we got the same interpretation. The two sides are equal and the third side is not equal. So this is an isosceles triangle. So likewise, if you get all three sides are equal, equilateral triangle, right? And if one of the square is equals to the other two squares, okay, so this can be an right angle triangle also, because one of the square under root 2 square is equals to 1 square plus 1 square, right? 2 is equals to 1 plus 1. Sorry, this is not an isosceles triangle. Though it looked like an isosceles triangle, we need to check for any right angle triangle is possible or not, right? So the hypotenuse square is equals to opposite square plus adjacent square, right? We have got this. So this is a right angle triangle. So this is how the students make mistake. They'll think, okay, two sides are equal, so this will be the right isosceles triangle, but you need to always check for a right angle triangle rule also with the Pythagoras theorem. So you can go really into a wrong way if you blindly follow. So now let us see another model. The shapes. So what are the shapes? The square, the rectangle, the rhombus, right? So they'll give four coordinates and they'll ask whether this forms a square or a rectangle or a rhombus. So how can we check? So let us do an example question here. So let us say a point A, which is 0 comma 1, point B, which is 1 comma 1, and a point C, which is 1 comma 0, and a point D, which is 0 comma 0. Right, will this form a rhombus or a rectangle or a square? How can we check? So for that we need to know the basic rules of a square. In square, all sides are equal. All sides are equal and the diagonal lengths are also equal. So this diagonal length is equal to this diagonal length. So then it is said to be a square. So all sides are equal, the two diagonal lengths are also equal to each other, right? Not to the sides. And for a rectangle, opposite sides are equal. Okay. And for a rhombus, same as a square, all four sides are equal, but the diagonal lengths are not equal in it. So if you find anything like all the sides are equal, don't go blindly to the square. It can be rhombus also, so we should check for a diagonal lengths, right? If they are equal, they are square. If they are not equal, they are rhombus. Now let us figure out which shape it this belongs to. So they are given in order. So let us find the, let us draw some diagram A, B, C, D, and let us find the side lengths. Right, AB. Difference between the x coordinates is 1 square, plus difference between the y coordinates. What is the y coordinate over here? 1 and 1. 1 minus 1 whole square, 0 square, which is 1. Now let us find the BC distance this side. Difference between the x coordinates 0. Difference between the y coordinates 1 minus 0 is 1 whole square, which is 1. Let us find the CD distance. Okay, CD distance. So difference between the x coordinates is 1, difference between the y coordinates is 0. X coordinates 1, y coordinates 0. So this is 1. And let us find DA distance. So what is D? 0 comma 0. What is A? 0 comma 1. Difference between the x coordinate 0, y coordinate 1. So under root difference between x coordinate 0, y coordinate 1. 1 square is 1. So we have seen all sides are equal. Then what can it be? It can be a square, it can be a rhombus too. So don't blindly go to the square, right? So we should check the diagonal length. So what are the diagonals here? AC and BD are the diagonals. So let us find the AC length. So what is A? A is 0 comma 1. What is C? 1 comma 0. So difference between the x coordinate square plus difference between the y coordinate square, which is 1 square plus 1 square. So 1 square plus 1 square is equals to 2. Right, let us find BD distance. Right, what is B? 1 comma 1. What is D? 0 comma 0. Difference between this square plus this square. So 1 square plus 1 square. So which is under root 2. Okay, so these diagonal lengths are also equal. So now we can say it is a square. If the diagonal lengths are not equal, then it could be a rhombus, right? If only two sides are equal, no, pair of two sides are equal, then it could be a rectangle. So these are the 5 models, and this is the most important chapter. And I'll post the section formula also. So comment down how this really helped you, or is this useful, or should I improve in certain areas, or you want some another chapter to teach. So just comment down in the comment section. And yeah, thank you for watching. Bye bye.